Hello everyone, my name is Zitong Xiao and I'm here to present my CS61B Project Zero N-Body Go Point section. I finished this project with my partner Jackson Gao. We decided to take the third idea that the guidance of Project Zero provides to us, which is to add the ability to control a spacecraft that is subject to the gravitational forces of the objects in the solar system. And now I can start running our program. And while running our program, I will also be explaining changes that we have made to the programs so it can achieve the goals that we want to add to the program. Oh, okay. Now, when we start running our program, we can see we have added a spacecraft. We decided to use the image of Kevin just instead of a regular image of a spacecraft because we want to make our program more fun. And a spacecraft is just like any other planet, but we add more features to make sure that we are able to control this spacecraft. The first feature we have added to the spacecraft is the ability to stop the spacecraft and at any position by using the mouse. For example, if I press the mouse, the spacecraft will stop at its position. Oh, like this. Okay, now we can see the spacecraft is moving, and then when I press my mouse, it stops. We achieve this goal by using the method in the Princeton Standard Draw library. Specifically is the method is mouse pressed. So this method returns to a Boolean value to tell us whether or not we have pressed our mouse. If the value is true, we will then set this. Oh, I can start a program again. If the value is true, we just set the speed of the spacecraft to 0, including the speed in x position and the speed in y position. And the second feature we made to this spacecraft is the ability to control the spacecraft to make it to move to any direction we want. We have two ways to do this. The first way is also through using the mouse, but this time we will not click the mouse, but we will click the space key on our keyboard and move the mouse to any places in the space. For example, and the spacecraft will move to the direction of the mouse. For example, now when I press the space key and then put my mouse here, we expect the spacecraft will move to my mouse. And we can do it one more time. Now I'm pressing my space key. Oh, sorry. Yeah, we can see the spacecraft is moving to the direction to the mouse. We achieved this goal by also using the functions, the methods provided by the Princeton Standard Draw library. Specifically, they are mouse X and mouse Y, and also is key pressed. So the is key pressed takes in a parameter, which is just the name of the key, and returns to a Boolean value to tell us whether we have pressed the key or not. If we press the space key on the keyboard, we can just write a method is key pressed with a space as the parameter. If that value is true, and now we can use the method mouse X and mouse Y to read the X coordinate to the X position of the mouse and the Y position of the mouse. After we get these values, we will apply a force in the direction of the mouse that is on the spacecraft, and that force will then be decomposed to the x, x, the force in the x direction and the force in y direction of the spacecraft, and will therefore will affecting the spacecraft's speed, so it will move to the direction of the mouse. The second way to control this spacecraft is by using our keyboard. We have designated four keys which are W, A, S, D to control our spacecraft. It's just like playing games. When we press W, the spacecraft will move upward. And when we press S, the spacecraft will just move downward. And when we press key D, oh, stop. I can start it again, no worry. So when I pressed the key D, it will just move to the right. And when I press the key A, it will just move to the left. And we achieve this goal by also using the method is key pressed from the Princeton Standard Draw Library. So specifically, we have four is key pressed method called. The first, each one will pass in the key W, A, S, or D. If the value is true, we will just, for example, if the value of is pressed W is true, we will just add another force, another proportion force in the y direction, in the positive y direction. And if the is key pressed A is true, we will add a force, proportion force to the spacecraft in the negative x direction in order to make sure it actually moves to the direction that we specify by our keyboard. Okay, and these are the two ways to control the spacecraft. But besides that, we can also see the spacecraft is affected by the gravitational force of this planet, especially when we move the spacecraft close to the sun. Oh, especially when we move our spacecraft to the sun, it would just have some weird motion because the sun has a huge mass and it will exert a really large gravitational force on the spacecraft. And the last feature we have added to our program is not really about the spacecraft. Instead, it's about setting the boundary of the space. So the spacecraft will not just move out of the space. That's super weird. To do this, we have four different situations need to talk about. The first situation is when our spacecraft is about to move out of the right boundary. In this case, we will call the update function. If by calling the update function, we detect the spacecraft is moving out of the boundary in the move is moving out of the right boundary, we will set its position to positive radius, which is the position of the right boundary, and its speed in the x direction to be negative and divided by 2 to make sure that the spacecraft is is moving smoothly when colliding the boundary. And the second situation is when the spacecraft is colliding to the top boundary. We will make its y position to the positive radius, so it will just be moved to the up boundary, and we will set its y we will set its speed in the y direction to negative to its original speed and then divided by 2. And the third situation is when the spacecraft collide collide to the uh, collide to the bottom boundary. In this case, we will set its position to negative radius, which is the position of the bottom boundary, and its speed to be the negative of itself and divided by 2. The fourth situation is when the spacecraft collide with the left boundary. In this case, we will set its x position to negative radius, which is the position of the left boundary, and then its speed in the x direction to be neg to be the negative of itself and then divided by 2. To, by implementing this method, we are able to have a smooth collision with the boundary of the spacecraft. So it will just behave like what we want. And yeah, this is our Project Zero goal point section. I hope after watching it, you like our program. Thank you.